Hey Java enthusiasts!
Welcome to today's session on multi-threading with synchronization.
From race conditions to thread safety, we're going to break it all down with a real-world code example.
Let's get started.
Multi-threading lets us run multiple parts of a program at the same time.
But when multiple threads share and modify the same data, we need synchronization to prevent errors.
In Java, we use the synchronized keyword to allow only one thread to access critical code at a time.
Multi-threading means multiple threads executing together. It improves speed but can create issues when threads share data.
That's where synchronization helps. It controls access and avoids conflicts between threads.
Suppose two people try to withdraw from the same bank account at the same time.
If there's no control, they both might withdraw before the balance is updated, causing it to go negative.
The synchronized keyword in Java makes sure only one thread can enter a method at a time. This protects the shared data and prevents race conditions or data corruption.
Let's begin with the bank account class.
Next is the withdraw method. This method checks if the balance is enough. If yes, it sleeps for 500 ms to simulate delay, then deducts the amount. It prints messages to show the process. The method is synchronized to ensure only one thread can run it at a time.
There's also a getBalance method that returns the current balance. Simple getter, not used in our main method, but useful if we want to check balance elsewhere.
Now let's see how we create the threads. This class extends thread. It gets a bank account object, withdrawal amount, and thread name. In run, it calls withdraw using the shared account.
Here's the main method that runs the program. It creates a shared bank account and two threads that try to withdraw. Thanks to synchronization, only one thread can succeed if there isn't enough balance. For both.
Let's see what the output might look like. Thread A is going to withdraw $700. Thread A completed withdrawal, remaining balance $300. Thread B cannot withdraw due to insufficient funds. The synchronized method worked. Only one thread was allowed to withdraw successfully.
You should use synchronized when different threads read and write shared data.
This ensures that one thread finishes its task before another thread starts using the same data.
So to wrap up, multi-threading makes programs faster, but can cause race conditions.
Synchronized helps manage access and keeps your shared data consistent and safe.
Want to explore more? Try Java's reentrant lock, thread pools, and concurrency APIs.
You can also build small apps to test thread behavior like booking systems or shared counters.
Thanks for watching. If this helped you, don't forget to like, subscribe, and leave your questions below.
Stay safe, code smart, and we'll see you in the next one.